Welcome back everyone, it's me Matt, thank you so much for joining me today, I really do appreciate you stopping by. Something else I really appreciate is the help and support that you guys have been giving me via Patreon, PayPal and subscription in donations financially to my channel. It really does mean a lot, and I know that sounds kind of cliche, a lot of YouTubers say this, but truly though, I cannot tell you how much I respect and appreciate those who have been supporting me, and if you haven't been, no worries at all, I'm just glad you're here to watch my content. So today we are talking about the Eryx missile. It's been around for some time, it's not news to many people I'm sure, but it is still being used today, as you can see in its capability of knocking out tanks. There is some upgrades that are happening to it, and it's still in service with certain militaries around the world. Quite a formidable anti-tank weapon system actually, it's still doing what it needs to do, not quite as technologically advanced as say the Javelin or the Spike, but still does what it has to do. And interestingly, I stumbled across a training video from the Canadian Armed Forces. Ironically, really, that I am also a serving member of the Canadian Armed Forces, that there's a video that talks about this missile, and I thought, well, it's going to do a lot better job than I am of discussing its overview and how it operates. Now, this video is really cool. It goes through, how to operate, what it does, how it functions, firing positions even, which with this system, as you can see, it's quite unique. You can either set it up on a tripod or have it man-portable and use it almost like a law. Now, Eryx is not exactly something we haven't seen before in the world of online media, let's say. Unfortunately, the Eryx missile was involved in a rather serious incident that involved Canadian Armed Forces personnel training with this weapon system, and you may have seen the video before, and we're going to have a quick look at it now so you understand.
Ici, 550 mètres, 2 T-54-55 se déplaçant de droite vers la gauche, en engager le premier à gauche. Tirez le second s'il vous plaît. Pointez! Dégagez prêt. Stand-by. C'est quoi, faut que je te dise?
So there, as you can see, a bit of an accident, weapons do fail, but it gave the Eryx a bit of a bad name across the military spectrum of people who really don't know much about, actual military experience or things that go wrong, and they put it as kind of, oh, the Eryx missile, that's the one that failed and popped out the tube and didn't go anywhere. Well, these things happen, we have duds. Unfortunately, it's just one of those situations you can't do much about. But still, it does what it has to do, and it's quite a formidable powered platform in the anti-tank world. So I'm going to let the video from the Canadian Armed Forces do the talking here. As I said, this video is not endorsed by the Canadian Armed Forces and is not there to use as training or reference material. It is there as entertainment purposes only, and I am not a subject matter expert, so the video is just there to give you an overview of exactly, what happened and how they trained on it in the day. So let's take a look.
The first tanks appeared on the field of battle in September 1916, when 36 British Mark I's trundled across no man's land towards German trenches during the Battle of the Somme. The effect of the tank was immediate. It was seen first as a terror weapon, and commanders quickly exploited its mobility and firepower. But it was also mechanically unreliable and easily knocked out by fairly light weapons. By World War II, tank design had undergone revolutionary developments. Anti-tank technology, however, lagged far behind. The best defense against a tank was often another tank. Then, low-trajectory field guns were developed specifically to deal with armored vehicles. As well as crew-served anti-tank artillery, one-man infantry weapons also emerged. One of the first was the British Boys anti-tank rifle, which fired a heavy caliber .55-inch armor-piercing bullet at very high velocity. A better solution came from the United States in the form of the bazooka, and another, in its German equivalent, the Panzerfaust. They still stand out as two of the simplest and most effective weapons of modern mechanized warfare. In more recent years, armies have relied on missiles, such as the TOW and AT-5 Spandrel long-range anti-armor weapons, which engage targets at up to 5,000 meters. Medium-range weapons, such as the Milan and the AT-4 Spigot, engage from 500 to 2,000 meters. Short-range anti-armor weapons are categorized into heavy, medium, and light types. Only those in the heavy category are able to defeat a modern tank from a frontal position. Eryx is such a weapon. Eryx is a lightweight, short-range anti-armour weapon, which can be transported to and set up on the battlefield very quickly. It's a rugged, well-tested system, which incorporates advanced munitions technology. The missile itself has 5 main assemblies. 1. The missile tube assembly, which consists of the missile tube, the interlock unit, and the junction unit. 2. The front plate assembly, which houses the front warhead, the missile battery, the safety and arming device, the gyroscope, the crush fuse, and the decoder. 3. The flight motor assembly, including the flight motor, the jet deflectors, the igniter, and the thrust-stopping device. 4. The main warhead assembly, which incorporates the main warhead, the pyrotechnic delay, and the thermal shield. And finally, the rear section assembly, which consists of the launch motor, the guidance wire, the beacon, and the folding fins. Weapon operation is accomplished in 5 steps. First, the launch. When the trigger button is pushed, the weapon battery powers up the firing post, which in turn powers up the missile battery. The missile battery activates the gyroscope and the safety and arming device. The missile beacon is activated and the firing post becomes synchronized to the flash rate of the beacon. This unique synchronization counters the possibility of downrange jamming. Finally, the firing post fires a pyrotechnic device, which retracts the retaining pin in the interlock unit and closes the circuit from the missile battery to the igniter. It is this action that fires the launch motor. The whole sequence takes 1 second. The second phase of the weapon operation is the propulsion phase. At approximately 0.5 meters from the launch tube, the flight motor is ignited by the unraveling of the guidance wire. The flight motor provides both forward thrust and directional control, and fires throughout the missile flight. The missile accelerates continuously to the target and has a 4.3-second time of flight to 600 meters. The third phase is localization. The firing post uses a wide-angle camera to scan for the infrared beacon transmitting from the rear of the missile. When it has locked onto the beacon, It switches to a narrow-angle camera to minimize vulnerability to jamming. The Site Localizer Guidance Computer, or SLG, compares the actual position of the missile in flight to the gunner's line of sight. It calculates the flight adjustments necessary to keep the missile on course to the target. The fourth phase is guidance. The missile auto-rotates throughout its flight due to the orientation of the fins and the direction of the propulsion. The missile determines its orientation from the gyroscope and sends this information to the SLG via the guidance wire. The SLG calculates the flight corrections and sends commands back down the wire to the jet deflectors, which then make the necessary vectored thrusts. Because the vectored thrust deflectors are positioned exactly at the missile's center of gravity, Eryx is extraordinarily agile and can react very rapidly to the SLG's commands. The fifth and final phase of the missile operation is impact. On impact, the crush fuse sends the firing signal to the safety and arming device. The safety and arming device then fires the front warhead. The front warhead is a small-shaped charge. It detonates and penetrates any reactive armor it might encounter, and also fires the pyrotechnic delay. The pyrotechnic delay includes the detonation cord. Its burn rate creates enough delay between the firing of the two warheads to ensure that any reactive armor is cleared and that the main warhead is detonated at optimal standoff distance. The main warhead is a 136 millimeter shaped charge. Upon detonation, its metal cone is shaped into a high-velocity jet, which flows through the center channel of the main motor. The jet is then free to penetrate the target's main armor. The thermal shield protects the main warhead from the main motor during the propulsion phase. In summary, Eryx operates in 5 phases: launch, propulsion, localization, guidance, and impact. This review summarizes the main points of Lesson 1. Eryx is a short-range anti-armor weapon, or SHRA, heavy. The role of Eryx is to provide short-range anti-armor fire. Its characteristics are range, penetration, flexibility, accuracy, and vulnerability. The system is made up of 4 main components: the tripod, the firing post, the missile, and the thermal sight. The firing post consists of 3 main assemblies: the sight assembly, the main assembly, and the junction assembly. The missile has 5 main assemblies: the missile tube assembly, the front plate assembly, the flight motor assembly, the warhead assembly, and the rear section assembly. Eryx operation is accomplished in 5 phases. The launch, propulsion, localization, guidance, and finally, impact. The missile has 3 built-in safety features. The igniter shield, to guard against electromagnetic radiation. The safety and arming device, to prevent the missile exploding prematurely. And the thrust-stopping device, to abort the flight of the missile. There is a danger zone and a caution zone in the backblast area to the rear of Eryx. The downrange hazard consists of an arc of 400 mils either side of the firing axis. There is a danger from blast within 100 meters when engaging targets at extreme short range. And while the tactically flexible Eryx can be deployed in built-up areas, the system needs a certain minimum amount of space when firing from enclosed or confined areas. A combination of standard operating procedures, training, and safety features means that gunners and loaders can operate Eryx safely and effectively and contribute to the operational capability of their units. Like many weapons on the modern battlefield, Eryx is a computer-based system. Even though it's built to stringent military specifications, it must not be subjected to unnecessary roughness or careless handling. A thorough system check of the weapon should be carried out at regular intervals, certainly after cleaning and whenever there is the slightest doubt about its serviceability. The firing post circuitry should be tested frequently, before live fire, after a shock, a fall, or a period of heavy vibration, such as air transport, every 30 days in theater, or after a period in storage. This test set is used to test the circuitry of the firing post. It is held and used by the first-line technicians in the unit. The test set is housed in a 28-kilogram container and can be operated using batteries or external power. A small computer is found embedded in the lower section, along with the optical module. The battery box. A set of cables. And the toolkit. In the cover is the self-test module. When the test set is assembled onto the firing post, it will take approximately 60 seconds to analyze and report that the firing post is acceptable for firing. The test set will inform the operator if the test set is malfunctioning, assembled incorrectly, or if the power supply is low. It will also inform the operator if there is a problem in the firing post electronics or the junction assembly. Like any piece of kit, especially one as advanced as Eryx, the environment has a big effect on performance. In high humidity areas, The missile should be kept in its metallic bag until it is needed. Once it is removed from the metallic bag, keep the missile and the other system components free from moisture. Be especially careful to keep the optical surfaces dry, and also the electrical connectors. The end caps from the tactical packing can be replaced even on a loaded missile tube. This will help to protect the missile from the negative effects of high humidity. In cold weather operations, it is very important to keep all of the optical surfaces clear of snow and ice. If these parts become obscured, the SLG may not track the missile properly. Snow and ice could also clog the missile indexing slots, the alignment pin recess, and the electrical connector. Prolonged exposure of the Eryx to direct sunlight and high temperatures must be avoided. The system is designed to operate in a temperature range between -31 degrees Celsius and 51 degrees Celsius. The reliability of the weapon is not guaranteed at anything beyond these limits. Having troops in NBC warfare situations presents no special challenges to the effective deployment of Eryx. Troops should proceed to decontaminate the missile systems in the same manner as any other piece of equipment. Wash down the firing post, ensuring that the eyepiece, optical ports, guide handles, and junction assembly are thoroughly cleaned. Make sure the tripod is also clean. And on the missile itself, clean the nose cone, the rear section, the protective foam padding, the interlock unit, and the junction unit. The missile can be considered to be uncontaminated if it has been properly sealed in its metallic bag during an attack. However, it is not possible to decontaminate the tactical packing, and this should be properly discarded. This review summarizes the main points of Lesson 2. Maintaining the Eryx system so that it operates reliably is essential. Three major components of Eryx must be cleaned regularly: the firing post, the tripod, and the thermal sight. The system must be thoroughly checked out and tested for serviceability. The circuitry of the firing post can be tested periodically using the test set. Eryx containers are marked in accordance with NATO standards. A black strip indicates a live heat warhead. While this blue strip indicates a practice round. Extreme climate conditions call for extra care and attention to the system. System components should always be kept as dry as possible. Whether in temporary or permanent storage facilities, the missiles should always be protected from physical damage, direct sunlight, extreme temperatures, rain, and snow. The metallic bag is designed to protect the missile from contamination during an NBC attack. But if it does become contaminated, all of the exposed components must be washed down and thoroughly cleaned in accordance with standing operating procedures for cleaning contaminated equipment. If ordered to do so, the components of the weapon system should be destroyed in the following order of priority: missiles, the firing post, the thermal sight, and the tripod. As with any weapon, performing the proper maintenance and correct handling on Eryx will ensure a high degree of reliability and effectiveness on the battlefield. Eryx is a short-range anti-armour weapon with an effective range of 50 to 600 meters. Gunners must adopt a stable fire position and engage targets quickly to minimize the chances of being detected and drawing return fire. The lethal capability of Eryx is due largely to its sophisticated technology. Several containers are required to protect the missile properly. Eryx missiles are shipped in groups of 4 in this logistic container. A fully loaded logistic container weighs 122 kilos. Each missile is encased within its own individual container. The individual container loaded with the missile weighs 22 kilos. Next, the missile is sealed inside a metallic bag to protect it from electromagnetic impulses. Within the metallic bag, the missile is contained in its field packing, which consists of 2 end caps and a carrying strap. To unload the missiles, open the logistic container. Withdraw each individual container by their handles. Push the pressure release valve, unscrew the air evacuation plug, rotate the opening lever, and remove the cover. Use the handle of the metallic bag to pull the missile from the individual container. Depending on the tactical situation, the missiles should remain in their metallic bags when stowed in the section vehicles. The metallic bags can be torn off easily. After the tactical packing is removed from the missile, it is important to inspect it for any damage. Look at the missile guide pins. Verify that the electrical connector and its cover are clean and functional. Check the missile alignment pin. Make sure that the copper ribbon cable running along the length of the missile tube is intact. At the rear of the missile, check that the 3 white electrical wires are intact, that the launch motor nozzles are unblocked, and that the beacon is undamaged. Choosing the best fire position for Eryx, in light of the particular environment and current tactical situation, must be considered carefully. Stability is the key to accuracy with this weapon. A gunner who maintains a stable platform can track the target more smoothly. At the moment of launch, there is a rapid loss and shift in weight. To minimize the destabilizing effects of this, the Eryx crew should use the system's tripod whenever possible. Eryx can be fired from the prone, kneeling, or standing positions. The kneeling position is used to deliver rapid fire at targets within 300 meters.
Darkness clear! Stand by!
Targets beyond 300 meters should always be engaged using the tripod. The prone position is recommended for all other live fire situations. Firing Eryx from a standing position requires advanced training and should be avoided if at all possible. In taking the tactical situation into account, there are two key areas to consider: cover for yourself and stability for the tripod. What is the nature of the ground? Does it afford the gunner and loader enough cover to set up the tripod, assume the prone position, and engage the target at over 300 meters? Make sure that the firing post has as much support as possible to minimize the effects of the missile launch and the subsequent weight loss. Do not set up the tripod on an angle. The firing post cannot be canted more than 10 degrees horizontally. And on smooth surfaces, block the tripod and make it as stable as possible. And of course, there must be a clear line of sight to the target. In cold weather operations, pack the snow down. This avoids giving away your position if the backblast disturbs the loose snow. Selecting fire positions during fighting in built-up areas involves additional factors. For example, the backblast area must be clear when firing from within a confined space. And the end of the missile tube can be no more than half a meter away from the firing port, so that the missile is clear of the building when the flight motor ignites. The Eryx gunner will increase his accuracy rate by choosing the right fire position according to these key factors. This review summarizes the main points of Lesson 3. Practicing the procedures for firing, transporting, and storing Eryx in the field will help to ensure that this weapon increases the operational effectiveness of our infantry. Eryx missiles are shipped in a logistic container as sets of 4. Each missile is packed in an individual container and further sealed in a metallic bag to protect the missile from electromagnetic impulses. Eryx gunners must adopt a stable fire position and engage targets quickly to minimize the likelihood of detection and counterfire. The prone position is recommended for all firing. Mount the tripod. Mount the firing post and verify that the safety catch is engaged. Make sure the firing post revolves smoothly and that the elevation handle tracks smoothly. Position yourself at an angle of 45 degrees to the center of the arc of fire. When firing from the shoulder, whether standing or kneeling, the firing post should have as much support as possible. Assume the kneeling position. Bring the loaded firing post up to the shoulder. Pull the weapon assembly firmly into the body. Firing the Eryx from the standing position requires advanced training. Assume the standing fire position. Bring the loaded weapon to your right shoulder and pull it tightly into the upper body. Wherever you can, find as much extra support as possible. It is critical that the gunner select a fire position that provides as much cover as possible from observation and return fire. Following these instructions for the use of Eryx in operations will add significantly to the tactical firepower of your team. As with all short-range weapons, the effectiveness of Eryx depends on the ability of the gunner to aim and engage the target quickly. To do this, the gunner must become familiar with the specific aiming characteristics of Eryx. This is the Eryx optical sight. It is a 3-power sight with a field of view of 230 mils. The sight's reticule has a thickened crosshair, which corresponds to a tank at a range of 600 meters. If the target appears larger than the thick crosshair lines, then it is closer than 600 meters, and therefore within range. If the target appears smaller than the thick crosshair lines, then it is farther than 600 meters, and must not be engaged. The pre-aim arrow is located 10 mils below the center of the reticule. It compensates for the depression of the sight at launch due to the departure of the missile. The gunner uses this arrow to take aim when firing. For a static target, the point of aim is at the bottom center. For a moving target, the point of aim is again at the bottom, but 3/4 forward. The gunner has taken up a proper fire position. He is holding the weapon correctly. He has taken careful aim. It is now time to fire the weapon. Here is the sequence of actions to take on hearing the command to fire. Estimate the range. Place the tip of the pre-aim arrow onto the point of aim. Track the target to get a feel for its motion. Breathe regularly. Tense your body. Press the trigger button and hold it down. And relax immediately after the missile launch. Keep the crosshairs and not the pre-aim arrow on the point of aim. And track the target, maintaining your point of aim until impact. The pre-aim arrow compensates for the firing post movement at launch, so the crosshairs should be on target once the missile is airborne. Eryx is extremely sensitive to flight corrections. Keep the track smooth. If a big course correction becomes necessary, bring the missile back on course as smoothly as possible. If the target momentarily disappears behind an obstacle of some kind, maintain the track and pick it up when it reappears. Concentrate on the point of aim. This is harder than it sounds, as the missile flying through your line of sight will be extremely distracting. Do not attempt to fly the missile onto the target. You must train yourself to ignore the missile flying through your field of vision and maintain your focus on the point of aim.